students, today we will discuss exemplar problems from current electricity. Okay, so first question is MCQ single option. Two batteries of EMF E1 and E2, E2 greater than E1 and internal resistance R1, R2 are respectively connected in parallel. Okay, as shown in the figure. So we have to find out the right option. The equivalent EMF of two cell lies between these two. That means equivalent is greater than E1 and less than E2. The equivalent EMF is smaller than E1. The equivalent EMF is given by E1 plus E2. Equivalent EMF is independent of internal resistance R1 and R2. And I think all of you know about this circuit is that if you have two batteries like this and its internal is R1 and another is R2, I think all of you know that if this is E1 and this is E2, what was the expression for the equivalent EMF? You remember it was E equivalent E1 R2 plus E2 R1 upon what? R1 plus R2. So this was the answer. If you remember, this was a derivation and this shows that E2 is greater than E1. It is written here. So that means E1 is equivalent is greater than E1 and less than what? E2. So this will be the answer for this case. Okay. So this is the first one question. So equivalent EMF lies between what? E1 and E2. Very simple. Got it? So this is the expression and this will be the answer. Now, question number 2. Which of the following characteristic of electron determine the current in a conductor? Now question number 2. Very simple. Current in a conductor is what? I think all of you know. I is what? NEAVD. Okay. So that means you need drift velocity alone, thermal velocity alone, no. Both drift velocity, thermal velocity, no. Neither drift velocity nor thermal. So first is the answer. Very simple, because here we need what? VD. We need drift velocity. Okay. So that means this will be the answer for question number 2. Very simple. Got it? Now come to the question number 3. Question number 3 is Kirchhoff junction rule is a reflection of, I think most of you must be knowing this answer, conservation of current density vector, conservation of charge, the fact that the momentum with which a charged particle approaches the junction is unchanged as the charged particle leaves the junction, the fact that there is no accumulation of charges at junction. But this is more than one option correct. So can you tell me Kirchhoff junction rule is based on the main factor was the conservation of charge. So one answer is this. Yes. And you know there is a very important thing that the accumulation of charge will not take place at the junction. So certainly question number 3, if you see, is the option for B and D. So B and D are the option. One is the conservation of charge and another is the fact that there is no accumulation of charges at junction. This is what Kirchhoff junction rule reflects. It says that charge remain conserved. Okay. So it is more than one option. Now come to the question number 4. Temperature dependence of the resistivity of semiconductor, insulator and metal significantly based on the following factors. Again, it is more than one option. So the question is that number of charge carrier can change with temperature. Time interval between the successive collision can depend on T. Length of a material can be a function of T. And mass of a carrier is a function of T. Now I think if you remember that what was actually the resistivity, and the answer is that if you remember the resistivity was rho. You remember it or not? And it was rho equal to m upon Ne square tau. So this was the resistivity. And what happens when the temperature changes? When the temperature changes, number of charge carrier can change with temperature. Yes, the factor is this. N is the factor. N can change. And the second option is that time interval between two successive collision can depend on T. Yes, that is also that is relaxation time. You know that if you increase the temperature, what happens? The relaxation time what decreases and resistivity increases. Length of the material, no meaning of that. Mass is not a function of time. So here these are the two options. That means A and B is the correct. N can change, relaxation time can change. That is the temperature dependence. And all of you know rho is equal to rho naught 1 plus what? Alpha delta T. This relation you know. So this is question number 4. Okay, now I am coming to the question number 5. Now question number 5 is a very short answer question. It's a theoretical. AB is a potentiometer wire as shown in the figure. Find the value of if the value of R is increased, in which direction will the balance point will shift this R. So answer, we can see what happens if I ask you if the R is increased. Okay, now tell me, when R is increased, what will happen in this case? If I ask you, if R is increased, the current will decrease. Now if we say R increased, certainly the current will what? Decrease. The current decreases. Okay, and as what? K is what? Constant. Potential gradient is constant, so it will increase in what? Increase in what? Balance length. So balance length will increase, so ultimately J will shift towards what? B. So this is the answer, towards B. As we know, because K is V by L and K is I R A B by L. So when I is what? Decreasing, L will increase. So this is the answer. Got it or not? So this is the concept for question number 5, how this potentiometer concept can work. Okay, coming to the question number 6. Question number 6, see the question. In an experiment with potentiometer, it was found that deflection is one-sided. Generally in the lab you will find one-sided deflection. And first, the deflection decreased while moving from one end of A to the end of B. Okay, that is decreasing. In second case, the deflection increased when the jockey is moved towards end B. In first case, it is decreasing. In second case, it is increasing. Okay, it is clear. Now, what is the question? The question is that which terminal, negative or positive, of the cell E1 is connected to at X, okay, and how E1 is related with E. And second is that which terminal of cell E1 is connected at X in case 2. In case 2 means when the deflection is increased. Now, if I ask you, the deflection in the galvanometer will decrease from one end. In the first case, it is decreasing. And if it is decreasing, certainly do you know what happens? In first case, E1 positive terminal is connected with X, like generally we have a less current in the galvanometer. Remember when we do the experiment. So in the first case, it is very simple. It is connected with what? X. Remember, this is how this will increase the length in the potentiometer. So what will happen? Moving one end of the, so it will, deflection will decrease while moving one end of the wire to the end of the B. So the first case is that if positive of cell E1 is connected to X and negative to Y. Positive is connected to S and negative to Y. Remember. So in that situation, current in the galvanometer decreases and that will increase the length of the potentiometer. So length increases. That is the first case. What will be the second one? In second one, what is happening? The deflection in the galvanometer is increasing. Now certainly it will be reversed. Okay, got it or not? So potentiometer, so end of the wire will be to the end of the B. We are taking this. So potentiometer, what happens? So it means negative is connected to X and positive is connected to Y. Are you getting in this case? So the current in the galvanometer what increases? यहाँ current क्या हो रही है? Increase हो रही है. So current in G increases. What you are going to do? You are going to connect positive terminal. So current will pass to the galvanometer. So it will increase in second case. So this is the case where current increases with increase in the length of the potentiometer wire. So these are the two cases we can compare for E1 where they are being connected. So it's a very important question. You can go through it and remember how E1 is related to E. Remember, E1 is always less than E. Remember, E1 is less than E. Driver cell is greater than always majoring cell. So this is question number 6. Got it? Now question number 7. Question number 7 is what? Short answer question. First, a set of n equal resistors of R each are connected in series to a battery of EMF E and internal resistance R. Okay, internal resistance is also R. A current of I is observed to the flow. Then the n resistance are connected in parallel. First they are in series, then they are. Then it is observed that the current is increased to 10 times once they are connected in parallel. So we have to find out the value of n. Okay, good. So how we are going to find out it? I think all of you know when it is in series, what will be the current? Current is, remember, it is EMF upon net resistance. Net resistance will be R plus what? NR. This will be in what? Series. And then what is if they are in parallel? Now when they are in parallel, I think all of you know the current we can consider is what? I dash. And E by it will be R. But when you take n resistors in parallel, so what it will be? Tell me. The equivalent resistance will be R by n. Are you getting it or not? It is in series, so it will be NR. When you take it in parallel, it will be R by n. Now what it states? It states that I dash is 10 times of I. This is the statement. So we will put it E upon R plus R by n will be 10 times of E upon R plus NR. So solve it out. You can solve it out, and if you solve it, R plus NR will be 10 R plus R by n. Are you getting it? And then you equate them. You take the common R1 plus n, and here also R1 plus 1 by n. Okay, so it is n plus 1 equal to 10 plus 10 by n. Are you getting it? And then you will take it on that side and you calculate it. If you get the answer will be, the value n will be 10 only. You equate them. Are you getting it? So the same thing you are going to get, because again n plus 1 will cancel out and it will become what? N equal to 10. Are you getting it? Some of you may be saying that how it happened. It will be n plus 1 by n and 10, and then it will be n 10. So this is how many? 10 is the answer. Got it? So you need n 10. Next, question number 8. Question number 8. Two cells of same EMF, but internal resistance R1 and R2 are connected in series. Okay. And what should be the value of R, this R, so that the potential difference across the terminal of the first cell becomes 0. Okay. So current is flowing in this. Now I think this question, I know that all of you know how to find the current. Already we have done. Current in this will be what? Both are in series, so this will be E plus E net resistance, because it has R1, it has R2. So what will be the net resistance? R1 plus R2 plus what? R. So current is simply 2E upon R1 plus R2 plus R. Got it? Now what is the question is that potential across this is 0. What is the potential across this? I think most of you know V is what? E minus what? R1. So it will be 0. So E will be what? I R1. Can I put I from here? Yes. What it is? 2E upon R1 plus R2 plus R into R1. Cancel it out and solve it. It will be R1 plus R2 plus R 2R1. Got it? And then you take it on that side. It will be R equal to R1 minus what? R2. This is the answer. So got it or not? So two cells of same EMF are connected and they are being resistance in external resistor. What should be the value of R, so that the potential difference across this becomes 0? You first calculate current in the circuit. Then we know that we can do in this also. So we got this one. And what was the relation of the external is that difference of their internal resistance R1 minus R2. Now question number 9. Now this is long answer question. Question number 9. Two cells of voltage 10 volt and 2 volt. Internal resistance are given 10 ohm and 5 ohm respectively, are connected in parallel with the positive end of 10 volt battery connected to negative pole of 2 volt battery as shown. That means the connections, the terminals are oppositely connected. Find the effective voltage and effective resistance of the combination, and you have been given the current distribution. What is the current distribution? If you see, I1 is distributed into what? I plus what? I2. That means you can write I2 as what? I1 minus I. So distribution C, I1 is distributed into two currents. So what we will do, that we will take the points A, B, C, D, E and F. And now we can apply the KVL, and we can apply KVL. Say we apply KVL on A, D, C, B, A. Are you getting it? A, D, C, B. We are going in this way. So I think all of you know 5I2, then it is opposite, minus IR, minus 2 will be equal to 0. So I can write 5I2 minus IR equal to what? 2. And in place of I2 I can write I1 minus I minus IR equal to 2. So this equation 5I1 minus 5I minus IR equal to 2. This is the first equation. Okay, got it? So we have applied this in KVL on this path. Then we'll take the another one. We can take the another equation on this. And this time I am going to take the outer path. Okay, like this. So which path I am going to take? F, B, C, E, F. Outer of the circuits, we can take this path also. So what is this? This is I1 coming here. So I can write 10 I1 and plus IR, and then coming to minus 10. Minus 10 equal to 0. So 10 I1, okay, plus IR equal to what? 10. This is the second equation. Got it? Now what do? We subtract 1 by 2. Now equation 2 minus and twice of equation 1. I am going what? Twice of equation 1. See, twice of this. So I am going to subtract it from this method. See here how I am going to do. It will be 10 I1 plus IR, okay, and then twice of this, okay, twice of 5 I1 minus 5 I minus IR, and it will be what? Are you getting it? 10 minus and 2 to the what? 4. So it will be like this. Are you getting it? This minus this. This is what? Twice of this minus. Then you solve it. So 10 I1 plus IR minus 10 I1 plus 10 I plus 2 IR equal to what? 6. You have to calculate what? 6. Okay, got it? And then this 10 I1 cancels out. IR and IR, 2 IR will become what? 3 IR plus 10 I, what? Equal to what? 6. So this is 3 IR plus 10 I equal to what? 6. Got it? I am taking 3 I common here. It will be what? See here, if I take common 3 I, so it will be R plus 10 by 3, and it is 6. Then 3 to just 6. Do you know I got IR plus 10 by 3 equal to 2. Now if you see this equation, this is equation number 3, and we can compare it with what? Do you know? E plus I. So what is the I? I is R plus what? Do you know? R effective into E. We can compare it with this. Are you getting it? Comparing, because E is what? IR plus R effective. And when you compare it, what is R effective? Tell me. It is what? 10 by 3 ohm. And what is E? It is 2 volt. Are you getting this answer or not? So final I am going to write is that E you get what? E you get 2 volt. Okay. And R effective you get what? 10 by 3 ohm. It's an important question. I can repeat it, sir. See, what we do, that we follow the Kirchhoff's law in both the loops, and then we calculate the two equations, and then we put it in such a form that it becomes that E is what? IR into the effective of the resistance. So we solve it like this, and 3I is taken common, where 3 will come down. So 3 6 are 2. So it will be like in this form, I R plus R effective equal to E. So what is E? 2 volt. What is R effective? 10 by 3. So this is the answer for this question number 9. Very important. Now last question, question number 10. Consider a circuit shown in figure. How much energy is absorbed by electron from the initial state of no current to the state of drift velocity? And second is that electron give up energy at the rate of I square R per second, that is the loss, to the thermal energy. What time scale would one associate with energy in problem? You have been given an electron density. I think all of you know number of electrons per unit volume, length of the circuit and area of cross section. So you have to first calculate the energy and then you have to calculate the time. Okay. So for that what you need is that if you see this circuit, okay, in circuit if you see we can find out the current. I is simply what? V by R. So I can put 6 upon the resistance is 6. The current is 1 ampere. And I think all of you know that what is I? I is NEAVD. We need a kinetic energy, so we need a drift velocity. So drift velocity will be what? I by NEA. Okay, can we put what is I? I is I think 1. What is N? N is 10 to the power 29. What is E? 1.6 into 10 to the power minus 19. And what is area? 1 millimeter square. So can we write 1 millimeter square into what? And in meter 10 to the power minus 3 square. So that means you get the drift velocity from here and the value comes 0.625 into 10 to the power minus 4 meter per second. After the calculation you will get this drift velocity. Okay, got it. So this will be the drift velocity. Now you have to calculate the kinetic energy for. Now energy absorbed. So energy absorbed by electrons, by all electrons, not one electron, by all electrons. So I think all of you know that energy is half mv square. So here energy for all electron will be n into half mv square, that is half mvd square. What is n? I think all of you know number of electrons per unit volume. So you will replace it into NaL into half mvd square. Are you getting it? Area of cross section and length. So n is 10 to the power what? 29. Area is 10 to the power minus 6. Length is 10 centimeter. So 10 to the power minus 1 meter. And half mass of electron is what? 9.1 into 10 to the power minus 31. And drift velocity you have already calculated. The value was 0.625 into 10 to the power minus 4 what? Square. So this calculation will give you the total energy and that comes 1.78 into 10 to the power minus 17 joule. So this is the first answer. What has been said? It has been said that you just tell the energy absorbed by the electrons. Now you have to find out the time scale when the loss is I square R. So time scale for the loss. Okay, time scale for the loss I square R. Okay, so then how we are going to get? The very simple is that ohmic loss. What is the ohmic loss? Is what? I square R. Are you getting it? So I is 1 square into 6. It will be 6 joule per second. So we will find out the time taken. Time taken will be what? T equal to total energy divided by per second energy, that is 6. So you calculate it, it becomes something 0.30 into 10 to the power minus 17. That means nearly 10 to the power minus 17 second. So this is how we can get the time and how we can get the energy. This was the question for the drift velocity and all these things. You got the drift velocity and then you calculated total energy and then energy loss. So all these questions were from the exemplar, very important questions. Okay, in next video we will discuss JEE main and NEET questions of current electricity. Okay, and thank you.